Okay, hi everyone. Thank you for joining the second week of IEEE Symposium on Data Analytics and IoT. My name is Fatemeh Jalali and I'm one of the organizers for this symposium. This symposium is a virtual technical talks over 8 weeks, and today is the first day of the second week. And we're gonna have a related talk on IoT and also data analytics related to IoT. So this symposium is a collaboration between IEEE IoT community, University of Melbourne Students Branch, and CIS, which is Computational Intelligence Society. Before starting and introducing, sorry, can everyone go on mute, please? Yeah, thank you. Yeah, before starting and introducing our host, I would like to mention that today is IEEE Day, as you see in my background, and I would like to say happy IEEE Day to all IEEE members and all engineers and all people who leverage technology to make positive impact on the society, on humanity, and make the world a better place. And also, before starting, I would like to mention that our guest speaker will talk about 40 minutes, and after that, we will have time for Q&A. If you're comfortable, you can type your question in the Q&A section. Otherwise, if you would like to talk, raise your hand and then I will unmute you and then you can ask your question. But both options will be available, whatever you prefer. So today we are very lucky. We have a very interesting and knowledgeable guest speaker, Vafa Shams from Wirepas, and Vafa is the head of APAC for Wirepas technology. Wirepas is an industrial IoT startup from Finland and started from a university in Finland, and then now it's a company working on mesh technology and edge computing. So Vafa holds a bachelor in electrical engineering from Monash University, and he holds MBA from Macquarie and Sophia University in Japan. And he also, he has been involved in telecommunications and cellular technology for many years in different companies like Ericsson, Alcatel-Lucent Bell-Labs, and working with different big global like major accounts such as Telstra, Vodafone, and Softbank. Vafa is also very active member to contribute to innovation and to a startup community in Australia as an angel investor, mentor, advisory board member, and an executive director in many programs like the TRaM programs in CSIRO, which is CSIRO on innovation and translational research. And he has many experience in engineering and research. We are very lucky to have him here. And today he is going to talk about next generation mesh technology. I'll stop here and I'll hand it over to Vafa for his talk.
Thank you very much, Fatemeh, for the kind introduction, and it's my pleasure to present to the IEEE Victorian chapter, the IoT community, and the Melbourne University and other universities. Good afternoon, ladies and gentlemen. So my name is Vafa Shams. I'm the head of APAC for Wirepas, and we are an industrial IoT company from Tampere, Finland, focusing on connectivity. We actually started our ANZA operation from my base in Melbourne in early 2017. And since then, we've gone from strength to strength, thanks to many novel ideas that have come from the Australian innovation sector, from entrepreneurs starting up their ventures and also the research sector, and also from some of the more established manufacturers that have used our mesh connectivity to design and build products that have succeeded in global marketplaces. Okay, so let's see if I can actually advance this. Yes. Can everyone see my screen well?
Yes.
Okay, good. So I'm here to discuss connectivity and the next leap of it, which is massive IoT. And I hope that if you don't remember anything about this presentation, that you actually remember the three main messages which are on this slide. That number one is that all that can be connected will be connected with no end in sight. And this is really the essence of the fourth industrial revolution. Number two is that the time and capability has arrived for devices to become autonomous in self-forming, self-healing, and self-provisioning from their own networks out of the box. And finally, is that the decentralized architectures deliver the scale, density, and performance. Our mission, should we want to accept it, is to rise above the cost to scale. Hence, this presentation tries to describe the journey that Wirepas has been on for the last 20 years and our continuum in the connectivity part. The next two slides are snapshots of some of the real use cases that we have achieved in Australia and elsewhere. And just to give you a picture of some of the environments where IoT needs to deploy and to tease your taste, and I will go through more use cases later on in my presentation. Okay, let's start with the problems in IoT. And to try and make my point, I guess I have researched some of the literature to explore the real problems in IoT, which I would like to share with you in the next few slides. I think what really resonates with me is that the IoT investment is not just about money, it's about time. And the common mistake, which actually plays to the heart of what we are trying to do, is that it has been a falsity to assume that the communication part of the project will just work, and very little planning and development is focused on that element. And that has actually proven wrong all the time. So it relates to the plumbing, as you know, the connectivity of the network relates to the plumbing of the network, where we focus on. And as I usually include my messaging, I see our roles as plumbers, which is quite unglamorous, but you only notice the plumbing when it doesn't work. And then, of course, something that everyone knows is that, you know, most of the IoT projects don't have a clear business objective. There are other types of sort of sources. So this is coming from GSMA just a few days ago. And the main takeaways are that the digital transformation journey is on. Everybody gets IoT nowadays. And most projects aim for cost saving. And the headquarters are driving most of the projects. And the drivers for the IoT projects are to derive benefits and to comply with the regulations on an equal footing. So what else? Is that the challenges remain, mainly integration to existing systems, to costs, and lack of skilled resources and data privacy concerns. And there is not a single dominant vendor of choice yet. In fact, we think that there is no vendor that can deliver end-to-end projects, or there's not many. Enterprises are thinking about using private networks, and yes, they're actually thinking about 5G cellular technologies, which are being thought by enterprises to ease them into IoT. I guess the question begs is that what are 5G technologies as we know them able to deliver to the problems which we highlighted before? Without any doubt, enterprise IoT is on the rise as a growing segment. And even after the shock of COVID and the economic crisis that will follow, most analysts agree that IoT is a key technology that will be increasingly deployed to ease the pain, to reduce costs and increase efficiencies, as we spoke about in many sectors like smart manufacturing, smart cities, smart buildings, and many more industries that will have to smarten up, so to say, to deal with this crisis. So in summary, if I went and summarized all the problem statements that I talked about and then came up with a solution, we believe that the connectivity solutions of tomorrow will have to offer solutions to many problem areas. So let's go through them. So the number one is that they have to be simple to deploy. So time and resources invested in installations and commissioning of solutions will outpace the cost of purchasing and even developing solutions, unless they are designed to be simple to deploy. Number two is that the scale of devices will render planning tasks simply uneconomical. Hence the need for autonomous connectivity networks that they make their own routing decisions. Number three is that the progression from dumb to smart solutions is essential as enterprises decide to progressively spend their budgets. So start with a smart, simple solution, monitor it, and gradually smarten it up when it proves its merits. Number four is that the low power networks take the cake, as once the demand for battery powered and at scale networks increase, so do the demands to be gentle to the environment and not weigh more on the landfills, which are quite full now. Number five is that today we have unlicensed ISM bands, which have many regional regulations for instance, sub-gig ranges, which differ from region to region. So if we have a 915 megahertz solutions, which is designed for Australia, it cannot simply function in 915 band in the US or a 917 megahertz band in South Korea, and certainly not in the 868 megahertz band in Europe and UK and so on. Meanwhile, the global 2.4 gigahertz band also caters for Wi-Fi, and the scale of the deployment of Wi-Fi will soon mean frequent interference between Bluetooth and Wi-Fi. So Wirepas believes that additional and global unlicensed bands are a certainty to cope with the demand of for wireless IoT solutions. Number six is that devices can wirelessly cover longer ranges, cater for more bit rates, and operate on low power will be increasingly more desirable. And finally is that the largest challenge remains delivering efficiency of scaling in connectivity networks without paying too much costs. So at this point, I would like you to sort of view a 1-minute video, which we produced a couple of years ago and still communicates some of our vision today, especially with respect to what we just discussed. And I hope the sound will come through.
In nature, an organism can only thrive through one thing: adaptation. The smartest, the most energy efficient and adaptable survives. Since the first industrial revolution, human productivity has soared through a combination of increased automation, energy efficiency, and connectivity. But still, our best efforts look meager in comparison to what nature has to offer. We still have a lot to learn. Nature adapts through DNA from generation to generation. That's what makes the life on our planet pretty much shockproof. Compared to the amount of data carried by a genome, our human-made devices are still quite primitive. Even the slightest change in the operating environment can render them useless. But they will evolve to enable a programmable world where we get data faster and devices become more adaptable. Wirepas connectivity is modeled after the way things work in the wild. More energy efficient, more adaptive, more intelligent without constant nurturing and rigid centralized control, without infrastructure and instructions. What we offer you is extreme connectivity fit for the real world that will help your business realize the true potential of the fourth industrial revolution. Wirepas. Things connected naturally.
Okay, so for those who don't know us, Wirepas is a Finnish company with headquarters in Tampere, Finland. You might be familiar with Finland as a country that has quite a lot of skills in radio communication and networking technologies, having been the basis for sort of headquarters for Nokia for so many years. We were incorporated in 2010, spinning off from a 10-year research project at the Tampere University of Technology. We are about 50 people, with the majority in Finland, but also physical presence in the USA, France, Germany, South Korea, India, and of course, Australia. Wirepas is extremely active in generation of intellectual property and standards. We hold 95 patents in 35 families of patents around mesh networking. And our business model is one of software licensing and royalties. So very much like the chipset model, rather than recurring data charges, which we think is a license to fail. And we have over 200 licensees, and they are generating north of 1,000 use cases in diverse sectors of economy, and our licenses range from very innovative startups to very large industrial brands such as Maersk, Prologis, Schaeffler, and Fujitsu, amongst many more. And then I will have a chance to go through some of these customers. So here is a snapshot of some of the customers that are working with us. And are happy to be on a slide, and you might know some of them, and of course there is many in Australia that are working with us. So here is what Wirepas focuses on. So first and foremost, the connectivity. Wirepas delivers reliable, optimized mesh connectivity. And this is delivered in software, which consists of the connectivity stack, open source reference software, and associated tools for diagnostic and positioning. Just for clarity, Wirepas do not produce any hardware, so we focus on delivering industrial-grade mesh software for massive IoT applications with high reliability and high performance. And last but not least, we do not do this alone. So in the IoT domain, as I mentioned, no company can deliver a full end-to-end offering. So our go-to-market consists of building strong partnerships so that together with our customers and partners, we can offer turnkey solutions to end customers. So when we look at the speed of adoption from various connectivity technologies throughout the time, we observe tremendous nonlinear growth curves in connecting people and places. So the technologies that connected people and places, like mobile communications and of course internet. But when it comes to connecting things, the curve goes almost vertical. The truth is that we don't know where this trend will go, but it is not too difficult to predict that very soon everything will be connected, that can be connected, will be connected in unprecedented scale and density into what we call massive IoT. So what is typical for things, we think, is that the lifetime expectations are much beyond consumer products, so 15 to 20 years. And quite interestingly, small 2.4 gigahertz radio, like what you see on this fingertip, is having the computing efficiency of iPhone 1 when it was released in 2007. So all the necessary computing and connectivity will move closer to the edge, less and less centralized functions and instructions, and more autonomous devices, self-forming networks, and self-healing when one or two of them fails. And you will have more energy efficient, more frequency efficient networks. And this is much how the evolution of IoT connectivity happened. So already a long time ago, there was local and small areas of connectivity designed, or connectivity technologies like Zigbee and Thread and Z-Wave designed, mainly for homes driven by traditional mesh networks. And then we had low power wide area networks which arrived, and these networks are wide area, sparse installations, and quite low bandwidth capabilities like Sigfox and LoRa and BIOT. And all of what I just mentioned are examples of centralized networks. So they need to have certain infrastructures installed and configurations managed from a central place. But when we go for massive IoT, that is decentralized. Any scale, any density, any location, and we call it next generation mesh. And the belief is that each and every decision in the network is done in each device in the network, and they are all autonomous. Any device can route their neighbors when it makes sense for an optimal network operation. You can address downlink, uplink, and peer-to-peer with gateways, and also gateway-less type deployments, which we have done a number of in lighting installations. In other words, in this type of scenario, the actual network is your device, or the device is your network. So here is an overview of Wirepas mesh architecture and what we deliver. So first and foremost is the Wirepas mesh stack, which is delivered as a binary that you can program to your radio device. And the Wirepas supports 2.4 gigahertz and sub-gigahertz bands and runs on multiple radio chipsets, namely the NRF52 series from Nordic Semiconductors and the EFR32 chipset from Silicon Labs. In addition, there are also the choice of a large choice of modules from hardware partners like uBlocks, Fujitsu, Murata, and others that have made the deployment of Wirepas mesh on radio devices much easier by removing the complexity of starting from chipsets and therefore reducing the time to market for hardware development. And then any device having the Wirepas mesh binary and the network credentials can join the network and establish upstream, downstream, and node-to-node communication and extend the network coverage by acting as a router for other nodes. Wirepas mesh is a decentralized network, which means that all the networking decisions are done by the node themselves. And this autonomous behavior is a significant benefit to our technology because it eliminates the need to plan specific routers or network controllers or routing tables. In practice, once the software is embedded in the device, there is little to no need for planning, commissioning, provisioning, and ongoing management of the nodes. For applications that are at scale, this is very significant benefit to the cost of ownerships and introduces great agility to future changes in the network. For instance, changes to the scale and the response to adverse effects through self-healing properties. We had a customer approaching us in September last year, and they asked us to increase our addressing field, which was 24 bits, capable of addressing 16 million nodes in a mesh to 32 bits, which can address 4 billion nodes in a mesh. And we couldn't believe this request until we had the second customer and third customer in December, and now we delivered that capability. So 4 billion nodes in a mesh is something that is realistic now. Wirepas provides also an SDK that runs on the radio CPU for application development. We also provide a set of application examples for sensing and asset tracking to get the companies started. And on the gateway side, Wirepas Linux gateway and cloud APIs are available in open source through the Wirepas GitHub. And you can use them as is or customize them for your own needs. Wirepas also provides 2 cloud-based tools which come with the software license. Wirepas network tool, which is for network diagnostics, topology visualizations, and network health monitoring. And then the Wirepas positioning engine, which uses the mesh network information to provide indoor asset localization. And last but not least, from the list of the companies that you saw before, Wirepas partners provide a wide range of sensors, tags, and gateway products, as well as software tools and platforms. And so this approach results in substantially high KPI for our customers, which essentially reduces the cost of designing, developing, and operating, and also lifecycle management of the products and solutions. So you see market advantages in scalability, in density, throughput, and battery lifetime of devices, all of which are very essential elements of massive IoT implementations. So I have kind of described the world that exists today. But I guess, when we're talking about the next generation, the future technologies, I guess this is the next 3 slides address that and are thinking in that domain. So when we look at the 5G technologies, what the 5G standard tries to address is about 3 folds. So first of all, you have it has to provide enhanced mobile broadband. This is exactly like how fatter the pipes should get to allow additional media reach demands, and which is very much addressed by the telco vendors and the 5G products. And it's not just about getting fatter and faster. Many driving applications for 5G also require ultra reliable low latency communications. For instance, connected robots or self-driving cars, or some of the frontline healthcare solutions that have come of importance during the COVID time, just to name a few. And last but not least is the massive machine type communications, or IoT. So the telco vendors of today have not had the time, resources, and the know-how to deliver any suitable alternative for the scale, density, and reliability which awaits them. The likes of NB-IoT and LTE-M and so on, these cellular technologies, they have basically peeled off the unnecessary features of the cellular standards, like cell handover, roaming, and other types of features which have not been designed bottom up from network and things. In other words, no telecom vendor is yet to design a proven standard valid for most of the IoT use cases, which are optimized for massive IoT. And this is perhaps where we believe that the Wirepas approach could be of immense utility. So this is an area that we are focusing on going into the future. So I guess I can always pose the question of, could the world hence expect that a new global IT standard in unlicensed band and become available globally? And this new IoT standard will use modern cellular technologies like the OFDM modulation and HARC error detection to provide reliability, and also operate in much longer ranges than 2.4 gigahertz, limited to a few hundreds of meters, that offers higher throughputs and doesn't require custom-made chipsets, and can adapt to the commercially available ones to deliver the cost to scale. And we believe the answer to these questions are yes, and that the decentralized mesh networks are the ones that are best suited to deliver to this panacea. And I guess one thing that I wanted to say that in terms of the cost to scale, basically today we are operating something like an average node price of something like a price of a bottle of water for networks of quite large networks at scale. I guess we're talking about, you know, 2 to 3 Aussie dollars per node for the eternal community connectivity sort of needs of that node. Just one last slide before I go to the use cases, which I guess is the excitement for me, and I hope more interesting for you, is that the applications or the solutions that we focus on, and I also need to say that Wirepas is not in the solution domain. So we are a technology provider, we're enabling, and our technologies enable quite a lot of solutions, but we have deliberately, as a matter of strategy, stayed off the solution domain, because I guess as a technology provider, if you also address the solution space, then you end up competing with your own customers, which is not the greatest thing. So the applications that we focus on are logistics and asset tracking. This is a very fast growing area. In fact, it's booming today. And here Wirepas deliver connectivity for location and end-to-end supply chain. So the connectivity is all the connectivity, the positioning server, and the algorithms for triangulations, etc., etc. Smart lighting for industrial and commercial buildings where reliability and low latency are key. The lighting systems use Wirepas for lighting control, but also the lighting becomes a network to collect sensing data or people or asset location in the buildings. And I have a few examples in my use case, and especially in Australia. Industrial domain, our customers and partners use Wirepas to reliably monitor the systems for preventative maintenance and condition monitoring, and also in the smart metering domain, where Wirepas is deployed in more than 2 million smart meters in Scandinavia and preparing the next generation of smart meters in India, Indonesia, and other markets. Okay, so by my calculations, I have a few minutes to go through use cases, and then we can open up for questions. So I mentioned Maersk. Maersk is the world's largest shipping company. As I mentioned, they can have now up to 4 billion devices in the same network. They are in the business of transporting these containers from one spot to another spot throughout the world. So the networks of the ports, the destinations that they go is actually a global network. And a container needs to go from mesh one to a number of other meshes before it reaches its destination. And they have been on the, I mean, we have been working with Maersk for the last 3 years. And this is after a number of years that they studied possible radio technologies for their type of requirements. This is what I talked about. So 1.8 million or now is going to 2 million smart meters connected by Wirepas mesh in the city of Oslo, the capital of Norway. So you can see the meter. The meter has, you can see it doesn't even have an antenna, an external antenna. It does have an internal antenna. And today we have connected about 750,000 electricity meters in a single Wirepas mesh network. That is the world's largest mesh network by a factor of 1,000 multiples. And with no infrastructure. So the network, which is the smart meters side by side, they are the network. So as I mentioned, the device is the network, and this is in a utility grade of service in in a utility network which has the coverage of 100%. It has the service level agreement of 99.9% reliability, is future proven, and the good thing about it is actually 99% free, because the mesh solution doesn't really require any recurring data charges. So the reason that is 1% not free is that I guess for every couple of hundred of these meters, they have to be a sort of a backhaul, which uses a connectivity, a cellular connectivity, and that is why it's the 1%. Here is Schaeffler. Schaeffler is the world's top 2 ball bearing manufacturer. It's a huge company that is operational everywhere, including Australia, in all of the facets of the industry, including mining and automotive, everywhere. And Schaeffler has just, this is what they just announced a few weeks ago, Schaeffler Uptime. So they have designed condition monitoring and sort of the UI for that condition monitoring, and a gateway to do condition monitoring for all types of sort of mechanical electrical devices. So typical application is several hundred assets in a single day, and they believe that they will get cost savings of about 50% compared with manual offline measurements. So as I mentioned, scale, density, power, and reliability is what we're going for. Here is a case for the world's largest commercial real estate operator. In other words, these guys are the largest in the world in warehousing management. So 1,500 devices that can communicate simultaneously. And this is in 1 meter cube. Is another world record in terms of what we can deliver. 1,500 devices in 1 meter cube without losing a single packet. So if you looked at the mesh, it has synchronous communication locally. The mesh itself is an asynchronous communication, which ensures that devices not to send messages on the same channel at the same time. And so what we have done in this type of use case is that there is a possibility to use main powered radios. We can actually detect 6,000 assets in a container in 30 seconds with 100 accuracy. This is an Australian customer, Coulon LED. So they are Australia's largest industrial light maker. They serve quite a lot of, they have an architectural lighting division, but also industrial lighting division. And industrial lighting division, they serve quite a lot of mining customers. So all the largest mining customers in Australia use their lights, and the requirement for those lights is that they cannot fail. And of course, in the type of environments that these guys operate, they cannot be a failure. So we started working with Coulon. So lights automatically form a self-managing mesh wireless networks across construction sites. So this is, as opposed to mining, is temporary construction lighting. The solution offers wireless condition monitoring that helps any production reduce downtime. Each light also continuously detects and reports on activities and other important sort of environmental changes through each floor on the site. And of course, you know that the construction site by definition is dynamic. The network can monitor and provide real-time positioning of various asset tracking tags scattered through the construction site. This is one other customer of mine in the Asia Pacific region. They're based in Singapore. And what the problem that these guys are addressing is quite a large problem. It's the problem of losing about 380,000 people every year due to deaths in harsh and hazardous environments like oil rigs or petrochemical facilities. You know, the type of sort of events that we saw in Beirut a few weeks ago, I guess they're not all that scarce. Of course, that level, the intensity was quite higher a few weeks ago, but you know, these type of events happen quite a lot in these type of environments. So you have a positioning solution which is designed to eliminate the inefficiencies and manual effort of current personnel. This is the tag which sits on a person. And this is an explosion-proof type of what we call an anchor point. This is also similar to this technology, but it's not explosion-proof. And then they also have sort of harsh servers and cloud servers that sits on the site and does all of the edge computing. Quite exciting. Then in much cleaner areas like I guess post offices. This is a post office with in Finland with smart lockers, and these lockers are communicating their needs to sort of a localized or on-premise cloud solution using Wirepas. This is very similar to Schaeffler, but this time is Sulzer, and Sulzer is the world's largest industrial pump maker, an Austrian company as opposed to a German. Schaeffler, and this is the condition monitoring system that sits on any type of rotating pumps or actuators for preventative maintenance analytics, and much like the case for Schaeffler, it brings quite a lot of cost savings. In roller cage tracking, so a roller cage is some sort of a pallet that rolls on wheels, and of course in huge warehouses and post offices warehouses there is like virtually thousands of these roller cages lying around. The problem is that no one really knows where they are when they want to use them. So the operators of the warehouses and the postal offices, etc., they keep on ordering more of these solutions. And of course, there was a need for a solution that could track where they were in order to sort of let the people who wanted to know which one to use sort of do that. So they actually, the company that makes this type of roll cager is basically bends metals every day. So this is the first digital platforms that they created. Of course, in the offices and commercial space, our technology is being used by 8 of the top 10 lighting companies, and many use cases. So smart buildings, you know, indoor lights, occupancy sensors, switches, air quality, asset tracking tags. This is one example where you use the connectivity sort of coming with instructions coming from a mobile phone to sort of do the theme setting and lighting control setting within a hotel room. So there could be like hundreds per building, lighting control, scheme setting, and heat mapping. This is another Australian company called Organic Response that has been acquired by a Swedish giant, Vodafone, and they do exactly that. So the human-centric lighting, you know, so the lighting that adapts to where the human sort of tracks, and it only illuminates where there is a need to do that. And of course, they are reporting something like 90% power reduction, quite large installations, and this is the type of heat mapping that they generate. So this type of input can be also utilized for adding efficiency, and or in the cases like we have today within offices, contact tracing and sort of social distance type planning. a totally different use case. This time our customer is actually Lindstrom. And Lindstrom is a towel maker. So very much like the people who stepped from creating roll cages, bending metals. These guys are towel makers, and they decided to put connectivity into the towel dispensers in washrooms across Europe. So hundreds of thousands of these type of implementations. You have the connectivity that we provide, utilizing sensors that are measuring the use of sort of dispensers, how full is the dispenser, and by doing that, they actually reduced 20% personnel walking during the day. Surprisingly, they actually increased the towel sales by 15%. And then they are also selling the data to facility owners and other users to say, to let them know how many people are using those washrooms. This is another one. I guess you may have seen this type of implementations even on cellular technologies. WakeUp that has a smart sensor that is health and safety solutions for construction sites and industrial sites. This is one you have never seen before. This is the detection of bed bugs in hotel rooms, which is actually quite a large problem, and especially in hotels in New York. So this is actually a Finnish solution, and I've met the CEO of this company and the co-founder, a very young guy that comes from Portugal and lives in Finland. Is now the #1 hotel solution that exists, and it has smart legs, and these legs have listening devices that can detect the movement of a bed bug, and if that movement is detected, then using the mesh networks with the other hotel rooms, I guess the signal will go down to maintenance to come and take care of it. Traditional solutions like smart city planning, lighting, the control of the lighting control on smart poles, and we have many of these type of solutions even in Australia and Canada, Sweden, France, a number of other places. This is a smart lock, which is from a company called Nokia in the US, and we have quite large installations of these smart locks. Again, traditional solutions like sensoring of high voltage substations in sort of power stations. And this is a solution in a petrochemical sort of setting that uses, has a device that is monitoring the valve, whether the valves are open or not. And yes, so I think I will stop at this point. I have exceeded by 3 minutes, but so there is quite a lot of information you can get from our site. In terms of downloads and use cases, we also have a YouTube channel, which has a number of our customers making the case known, and then of course the GitHub for Wirepas for all the open source assets, and then of course the partner and customer ecosystem on the site. And of course I'm here to answer any questions.
Right. Thank you very much, Vafa, for your wonderful and informative talk on mesh technology, and also introducing the reliable, scalable, and also energy efficient connectivity, which is essential for many IoT environments, as you also showed in your use cases. So now we have time for Q&A. As I mentioned at the beginning, you can type your questions in Q&A section, or you can raise your hand and then I'll unmute you and you can ask your questions if you would like to talk.
No questions. That's fantastic.
I've got one question for
Everything
you.
is crystal clear.
Yeah, it was great talk, and so I will start the first question, and maybe the audience will continue. So one of the concerns with distributed like applications, and especially with those that they are dealing with many sensors and connectivity of many devices, generally is security, and people are afraid of security. So can you just like very high level elaborate on the how your technology like protect from like in terms of security, protect the devices, any things that you can, I know that many things you're not able to share, but if in high level you can explain the security solution, that would be good.
Sure. So let me see if there's any slides I can you see this slide?
Yep.
Okay, so in terms of security, I guess this is one thing that we have to note here is that the mesh networks are usually kind of closed systems. So you have within a petrochemical, say, industry or petrochemical site, you have a number of sensors that are connected. They are all together a very closed ecosystem. So they're not connected to a base station, which is a public telecommunication network. So inherently, they are a lot safer. But then it's like a WLAN, so anyone can tap into it. That's not right. You may have actually heard about some of the spoofing risks that exist on the BLE protocols. We have totally eliminated that, and the way we do it is that essentially every node that sends a packet on using Wirepas connectivity, we apply 128 sort of bit encryption. So the key to that encryption has to be sort of produced for the network to allow the node to send its packet to get routed all the way to the central system, if that is really the goal. So for more of the utility type graded service, like the smart metering solution, which I showed is actually a public network. Not only the 128 encryption of Wirepas is also, which is on every message is being used, but also the customer has also decided to do additional security on the application layer, which is here. So if this is the OSI layer and this is the application layer, we do the encryption here, and they also place the additional security solution on the application side. So you have double security. Yeah. If that answers your question.
Yeah, it was. That's great. Thank you. We've got one question in the Q&A session. If you also click, I can read that. Thank you for your interesting presentation. In your presentation, you compared Wirepas and other network technologies, Bluetooth, Zigbee. Please explain more about your comparison, for example, the scale.
Okay, so very happy to. So if you remember, one of my sort of slides was so talking about sort of traditional mesh networks. So this is a traditional mesh networks like Zigbee. You need to have, and I actually called it centralized. Even though it's a peer-to-peer network. And the reason I call it centralized is that you actually need to plan for a leading node or a routing node. So you can, of course, do that for a very small application, like in a home-based application. You can set a node as a leading node or a routing node. But you know, when you have tens of thousands of similar nodes in one application, then the task of routing table sort of becomes almost impossible. I usually like to sort of simplify things just to make an impact. You know, like the scale is a major challenge. Just imagine if I said to you, and I know all of you are fascinating cooks, but if I said to you that, look, I'm bringing my family to your house for dinner, even though you didn't invite me, and there is like 3 of us, I'm sure you can, I mean, you will be disturbed, but I'm sure you can actually do a good job. But if I made the claim that I will bring 600 people to your house uninvited and unplanned, then I think the question of scale is that it really cannot be done. And so we think that centralization in networks that require massive scale it will just kill the scale. One other analogy that I can offer is mesh networks are like pyramids, and the base of the pyramid is where you have the volume and the scale. And they're all trying to communicate to the apex of the pyramid, where there is usually a gateway or that connects to centralized systems. And that is where congestion happens. You know, it's the laws of physics. So our approach in trying to not to flood the mesh or be able to throw in additional apexes, it makes our mesh totally scalable, and this is something that hasn't been done in some of the traditional mesh. So I guess this type of presentation that are made in terms of scale is what the reality is, and we see that every day.
Yep, that's great. We've got a few other questions. One is, how do you connect different types of sensors to your network?
Yes, so I mean any network that so basically what Wirepas does is that, and I mentioned to you that we are not on the hardware side. So say if you have an NRF52832 device, so it has to be compatible hardware with what we do. Actually, theoretically, we are hardware agnostic, because we have nothing to do with this physical layer, as you might remember in my sort of OSI stack slide. So, but because it takes quite a lot of effort in testing a radio profile, so that we can actually offer a software on that implementation, we run on Nordic and we run on Scilabs, and of course all the modules. So if you have a Nordic device that is sort of having a Wirepas radio profile flashed onto his onto the radio transceiver, then that device can also interoperate with another device from Scilabs or other types of Nordic devices.
Yep. Okay, that's great. Another question is, in terms of positional proximity tracking, what accuracy in position can you obtain?
Okay, so it's a great question. Let me just show you this. So the way that the mesh operates is that, of course, you know, this is, we have like thousands of these type of devices, and I guess show thousands of these type of implementations, including the ones that are showed in harsh and hazardous environments like petrochemical site or oil and gas site. So this could be lights, or this could be just you know, anchor points. You know, these are devices that you set to set the mesh. So these are fixed location devices, so they're not moving around. And when you set this implementation, you know, that you usually pick up a Google map and you align this node on top of a Google map. You get the coordinates for that. It goes into our backend system, which is the positioning calculation. When you do A, B, C, and D, then you have the corners of the building, and that's enough. Then you have then you have sort of, sorry. Then you have sort of the light green nodes in there, which are the mobile tags. You know, they can be attached to assets, to people, to tools, to whatever you want to tag. At regular intervals, these light green tags take a radio measurement. So they take a measurement of all the anchor points, which is within their range. They send it through the backend system, and then that is where we do the triangulation. So this type of system is good for, I would say, 3 meters to 20 meters type accuracy. Of course, it depends on how close these anchor points are to each other, but this is not this is not a real-time type absolutely perfect positioning, but it's at the price of 1/20th of those systems, so it's extremely economical.
Yep. So we are over time, but we've got 2 more questions, and if you can just very quickly answer them, that would be good. One question is that can anyone use Wirepas for R&D activity?
Can anyone use? No. So, I mean, of course, you can go to a GitHub, and then you will find SDKs and some generic applications that is there. The binary has to be licensed.
Yeah, all right. And the last question is that, does the system support near real-time messages?
Yes, so we support lighting applications. So lighting applications, usually when you flick a switch, you expect the light to come on within the human perception sort of tolerance, which is less than 250 milliseconds. So if I say that I can deliver end-to-end 250 millisecond low latency, that is almost near real time, right?
Right. Thank you. That's great. Thank you very much, Vafa, and all the participants and everyone that joined us. It was great. And we're gonna have 2 more interesting talks this week and also in the next 6 weeks. Please join us for the other talks. And thanks again, Vafa, for your time and for your very interesting and informative talk.
Many thanks for your attention.
Thank you. Bye.
Goodbye.
Bye, everyone.
Bye-bye.